So this is the 2016 Leaving Cert Higher Level Paper 2, and we're looking at question number 2. A point x has coordinates minus 1, 6, and the slope of the line xc is 1/7. So here's our point x and the line xc, the slope of which is 1/7. Part A says find the equation of xc. Give your answer in the form ax plus by plus c equals 0, where a, b and c are elements of the set of integers, the z set. Okay, well, the equation of a line, one of the formulas we have for that is y minus y1 is equal to m bracket x minus x1. So we already know that the slope of the line is 1/7, and we know a point x is on the line, minus 1, 6. So this is going to be x1, y1, this is going to be our coordinate, and this is going to be our m value here. So we're just going to sub those in. So we have y minus 6 is equal to 1/7 bracket x minus 1. So just to be clear there, we subbed the x minus 1 in here, the y1 in there, and the m value in here. So we're now just going to tidy this up into this form here. So that's going to be, well, let's see, the easiest thing to do would be to multiply across by 7 to get rid of this fraction. So you get 7y minus 6 by 7 is 42 is equal to 7 by 7 is 1, so you're just left with the x minus 1 is plus 1. And now we can just bring this over here to become a negative 7y, and the minus 42 over here to become a positive 42. So that gives me x minus 7y plus 43 is equal to 0. And there we have our answer in this form, where a, which is 1, b, which is minus 7, and c, which is 43, are all integers. So that's part A. Part B, C is the center of a circle S of radius 5 centimeters. So here's our point C, the center of a circle S, and the radius is 5 centimeters. The line L, which has a equation 3x plus 4y minus 21 equals 0, is a tangent to S and passes through x as shown. Find the equation of one such circle. Okay, well, if they're asking for the equation of one such circle, that would indicate there might be more than one, but we only need one. So let's have a look at the diagram again. We have the line L going down here, and we know the equation of that line. And we know the radius of the circle. So if we're trying to find the equation of a circle, we need, to get the equation of a circle, we need the radius and we need the center. So we can see here that the center is marked minus g minus f. So we're going to be looking for that. We're going to be looking for minus g and minus f. And we already know the radius. Okay. So we know the equation of a circle is x minus h squared plus y minus k squared equals r squared. That's when h, k is the center and r is the radius. So we already know the radius of our equation is going to be 5, so we're going to have 5 squared on the right, and we're just looking for h and k, the center. Now, they've named the center over here minus g and minus f. So we're looking for two unknowns here. So that would kind of indicate that there might be simultaneous equations involved if you've two unknowns. So can we set up some equations with minus g and minus f involved? Well, because we know the distance from a point to this line here, there's a formula in your tables book for the distance from a point to a line, and it's this one down here. So because we know the distance is 5, the distance from this point, the center, to the line is 5, we can set this equation up. So we can say that the distance, which is 5, will be equal to the modulus of ax1. Now x1, y1 will be the point. So it's the distance from a point to a line. So the point will be x1, y1. So we know that the point is minus g and minus f. And also we know our a value here is the number in front of x. Our b value here is the coefficient of the y. And our c value is the constant here at the end. So we know a, b, and c for the line, because this is the line, the line L. So, and again, those a and b values, then b appears there again, and also a appears there. So we have an a and b, and so our x and y is the minus g minus f. So what we have now in the formula is the modulus of a, which is 3. So it's 3 by x1, which is this is x1 here, minus g. So it's 3 by minus g plus b, which is 4 by y1, which is minus f. And then we have our plus c term, which is minus 21. And it's the modulus of all that over the square root of a squared, which is 3 squared, plus b squared, which is 4 squared. Okay, so tidying this up a little bit, we got 5 is equal to modulus of minus 3g minus 4f minus 21, and that's all going to be over the square root of 3 squared plus 4 squared. When we do this in our calculator, we get 5. Okay, so now we can multiply both sides by 5, and that gives us 25 is equal to the modulus of minus 3g minus 4f minus 21. Okay, so, well, if the modulus of something is 25, well, that means the something, so the 25 is equal to, or this is equal to positive 25 or minus 25. So we can set up these two equations. So minus 3g minus 4f minus 21 is equal to 25, or minus 3g minus 4f minus 21 is equal to negative 25. So we can tidy up each of these. So if we bring the minus 3g minus 4f over, make it positive, gives us 3g plus 4f. Leave the negative 21 here, but bring over this 25, that becomes negative. So that gives me negative 46. That's one equation. Or indeed, on this side, if we bring the negative 3g and negative 4f over, they become positive. Leave the negative 21 here, but bring this negative 25 over and make it positive. That leaves us with a 4. So there I have two equations. Now these two equations can't be solved simultaneously because you have 3g and 4f, and 3g and 4f, two different possible values for that. So you can't solve that simultaneously. So we need to somehow create another equation. So what else do we know about minus g and minus f? Well, if we go back to part A, we see that minus g minus f, the point C, is also on the line xc, which we know the formula, or the equation of rather. So if this point is on this line, that means it will satisfy this equation. So we're allowed to put this minus g minus f value in for x and y. So that's what we're going to do to create our second equation, or our third equation. So I'm going to box this area off here. I'm going to write down the formula, which is x minus 7y plus 43 is equal to 0. That's the equation of the line xc. And now we're going to sub in the values minus g and minus f. So it will be minus g is in for x, and minus f is in for y. And now we're going to tidy this up. So that's going to be minus g, minus 7 by minus f is plus 7f. And we're going to bring that 43 over to make it a negative 43. And if I just put the, and I'll leave it like that, negative 43 there. So there's another equation, okay? So now, if I solve this equation here with this one, or with one of these two, I'll be able to find g and f, or minus g and minus f. So I'm going to solve these two here simultaneously. So let's scroll down a bit here. If I have 3g plus 4f is equal to 4, and underneath, if I times this here by 3, if I multiply this equation by 3, that will give me minus 3g plus 21f is equal to 3 by minus 43 is minus 129. And I did that because now I have 3g and minus 3g here, which I can eliminate by adding. So if I add these, the g terms give me 0. 21f and 4f is 25f. And 4 minus 129 is minus 125. So if I divide both sides by 25, they cancel on the left here, leaving me with f is equal to minus 125 over 25, which is minus 5. So that's my value of f. And now I can sub that back into any equation that I like to find g. So I'm going to take this one here. So if I have 3g plus 4, instead of f now I know it's minus 5, and that's equal to 4. That gives me 3g minus 20 is equal to 4. I can bring that 20 over here. It will become positive. And I have 3g is equal to 24. So dividing both sides by 3 leaves me with g is equal to 8. So I now know f is minus 5 and g is 8. So that means if I'm looking for the equation, if I go back up here, I was looking for the equation of the circle. The center of the circle is minus g and minus f. So I know the center of the circle then. The center of the circle is going to be minus g, which would be minus 8, and minus f, which would be minus 5, which would be 5. So that's the center of the circle. So the equation of the circle then would be x minus h, which is the first term, so x minus 8 all squared plus y minus 5 all squared is equal to the radius. So the radius of the circle, if you remember, was 5, so 5 squared. So that gives me x plus 8 all squared plus y minus 5 all squared is equal to 25. And that finally is the equation of the circle and the end of the question.